right, let's get a start here. Keep in mind, if I could factor x squared plus 4 without, without using imaginaries or irrationals, then I would. But in this case, we're better off leaving it as a quadratic. So the form would be a over x plus bx plus c over x squared plus 4. There we go. All right, now you switch modes and you start adding fractions together by getting common denominator. There we go. All right, now let's follow our algebra nose, just distributing that a in. And then same thing with the x and the bx plus c. So we'd have bx squared plus cx. And it would be all over x times x squared plus 4. Okay, now take a moment and just kind of look at where you are in the grand scheme of things. So denominator battle, fought and won. And now let's move on to forcing the numerators to equal each other. So from here, I'm not going to write the whole fraction anymore. I'm just going to write the numerators. So we need 1 to equal. And now I'm going to reorganize this numerator on the top over here by descending power of x. So I have a plus b x squareds. So I just grouped those together and factored the x squared out on the right. Plus I have cx, that's the only x term it looks like. And then my constant term is 4a. Now on the left, that 1, I'm going to need to think of that in terms of how many x squareds and how many x's do I have. So 1 is the same as 1 plus 0x plus 0x squareds. And for that reason, my system of equations would be that 0 would have to equal a plus b, or a plus b would have to equal 0. And then similarly, c here would have to equal 0. And 4a would have to equal 1. So we already know what c is, and it's easy to divide both sides by 4, or just think about what a would be. So a would need to be 1/4. And then you could back substitute into row 1 and figure out pretty quickly that b would need to be the opposite of 1/4. Okay, so with that said, what would that mean for our conclusion? Remember, you always want to take your constants and back substitute into your form. So our conclusion would be that 1 over x times the quantity x squared plus 4 would equal 1/4 over x plus, actually, well, plus, I guess, negative 1/4 x plus 0 over x squared plus 4. Okay, now this is pretty unsimplified. I hope it makes sense. Like having fractions within fractions is considered very unsimplified. So I'm going to simplify that by writing it as 1 over 4x. And then similarly, this fraction over here, we could write as, it's pretty unsimplified to say adding a negative. So let's just say minus 1 over 4 times the quantity x squared plus 4. And you could always distribute that in if you want, but I think I'm going to go ahead and just leave it like that. There we go, fraction decomposed. All right, my friends. One last case here. Let's make sure that you know the move that you're going to use for any time you're given what's called an improper fraction. So that's our last special case today. So we're going to write the partial fraction decomposition for the quantity 2x cubed plus x squared minus 7x plus 7, closed quantity, divided by the quantity x squared plus x minus 2. Now let me make sure that you know what we mean here by this being an improper fraction. So you've got degree 3 over degree 2. A rational function is considered improper anytime the degree for the numerator is not less than the degree of the denominator. So just really quick, even if the 2x cubed was not in the problem, this would still be considered an improper fraction. But if I was to get rid of the x squared, then all of a sudden you have a proper fraction because the degree of the numerator would be less than the degree of the denominator. Okay, but you do have all those terms. Let me bring them back, okay? So in a situation like this, the first thing you're going to do is you're going to write your improper fraction in mixed fraction form. So I'm just going to leave that as a hint as to how to get started, and then I'll go through it with you in the next video. Best of luck.